So for solubility, we have the phrase like dissolves like, which essentially just means that like substances will dissolve each other. And what that means for us mostly is that your polar plus polar, oh my god, polar are soluble, as well as a nonpolar plus a nonpolar are soluble. So what exactly does it mean for something to be soluble? In just simplified, it just means that it readily goes into solution. As in, it will dissolve into the solution easily. Like, you won't have to boil or do anything to it. So take, for instance, if you were to put sodium chloride in water, like, no matter what you do, it's going to stay in there. Like, take, for instance, if you're making, like, broth or something, and you had boiling water, and you were to add sodium chloride to it, you still have the salty water after you boil it, like, after it's mixed and boiled. You can't burn out the sodium chloride, essentially. Like, you'll have salty water. And then for something to be insoluble, it just essentially means that it won't go into solution. Go into solution. So that just means that they won't mix at all. So if you take, for instance, oil and water, you try to mix oil and water, it won't work out, because even if you were to shake it vigorously and it kind of seems like you just have this weird blobby mess of things, you leave it to set for a little bit, and when you come back, you're going to see the clear separation of the oil and water. I've got to dot my I, but okay. You'll see the clear separation, meaning they're insoluble. So then, because of this, like with solubility, there comes this thing known as a precipitation, which is essentially you have a soluble substance plus a soluble substance will give you something insoluble. The insoluble thing is your precipitant. So take, for instance, if we were to do silver nitrate, which is soluble, so it gets the aqueous subscript, plus sodium chloride, which I just said was soluble. That should say aqueous. Okay, so then what that would give you is that you just have this kind of double substitution of the first things. You end up with silver chloride plus sodium nitrate, which sodium nitrate is soluble, but silver chloride is not, so therefore it gets the solid subscript. So this thing is our insoluble product, which makes it our, oh my god, precipitate. Yeah, so essentially it's your insoluble thing. So then, right, you guys are probably wondering, like, wait, how did you get that something was insoluble or soluble? And it's just, if you guys remember from Chem 1, you have your solubility rules. Solubility rules. Right, so we're going to go over those just because I don't know if you guys remember them. And just because this is a solubility review, so we have to go over the solubility rules. So then, soluble. If you guys remember the acronym Kashinga, which I just pronounce it Kachinga, because Kashinga. So your first C stands for chlorate plus perchlorate. Your A stands for acetate. Your S stands for sulfates. Your H stands for halides. Your N stands for nitrate. Your G stands for group 1 elements, which just means all the elements in the first column of the periodic table. And then your other A stands for ammonium. Right. So then all of these are soluble in water, except for sulfates. They have exceptions where if you add them, exceptions to these things, they will become insoluble, and that is with barium, strontium, calcium, mercury, lead, and silver. Yeah. So if your sulfate is ever mixed with any of these, it becomes insoluble, and your halides also have exceptions. And those exceptions are mercury, lead, and silver. So it's just all of these are soluble in water, except sulfates and halides when added to these things. But other than that, they should dissolve in water. So then on the other side, you have your insoluble substances, soluble, which this acronym is the COPS with 2 C's and 2 S's. So I guess it would be pronounced like COPS, but I digress. And you have your chromate, carbonate, OH, which is also known as hydroxide, your P, which is phosphates, your S, which is sulfide, and your other S, which is sulfites. Right, so your insoluble compounds, they're not soluble in water, with the exception of group 1 and ammonium for all of them, except for your hydroxide. Those things exception are group 1, barium, I forgot my charges, okay, there, and strontium. So what that means is that all of these are insoluble unless they're all mixed with a group 1 element, then they become soluble. And with NH4+, which is ammonium, except for barium, that's group 1, no, not barium, except for hydroxide, that's group 1, barium, and strontium. So if you see them mixed with that, then they become soluble again. So then let's do some examples of just labeling things as soluble or insoluble. So then let's take strontium sulfide. Strontium sulfide. So sulfide is insoluble with the exception of group 1 and ammonium. Strontium is neither group 1 or ammonium, so therefore this is insoluble. Okay, so another example. Let's take ammonium carbonate, which is NH4, CO3. Yeah. So then carbonate is insoluble because it's our second C, unless we mix it with group 1 or ammonium, and this is ammonium carbonate, so therefore it is soluble. So then let's just do silver chloride, which chloride is a halide, so that's soluble, but with its exceptions, it's mercury, lead, or silver. This has silver, so it's insoluble. And then one final one, let's do calcium phosphate. So calcium phosphate has a charge of 3, so there's 3 of those. 2. Right, so we have phosphates, which are insoluble, unless it's group 1 and ammonium. Calcium is not in group 1, so this is insoluble. So yeah, that's pretty much it for your solubility review. It's just remember your rules and the exceptions of what's soluble and what's insoluble, and you should be able to determine like the solubility of something.